public discussion on climate change is bedeviled by a lack of context. And you've often heard independent scientists criticised, and in fact Professor Courtier referred to this, as not being real climate scientists, whatever a real climate scientist might be. Now, the people that use that terminology mean you're not a meteorologist or an atmospheric physicist or a computer modeller. In my view, that group constitutes about 20 or 30% of climate science expertise. In their view, it constitutes 100%. You will see during my talk where I think the balance of the context lies, and it lies in many other disciplines, and one of the very most important is earth sciences. My talk has two parts then. The first part is about context, and it's not particularly coherent in the sense that every slide follows from the previous one logically. Rather, it's a series of spot examples that I will give you to make you think about what is the context of this 0.6 degrees of gentle warming that we had in the late 20th century. Because we probably did have, well, if not 0.6, that might have some urban heat island effect in it, but certainly we had a few tenths of a degree of warming in the 20th century, and I want you to think about that in context. Then the second part of the talk I feel very uneasy about because I'm a scientist. And unfortunately, I'm going to talk about policy. And I feel, firstly, I don't particularly have expertise there, but secondly, one loses one's scientific objectivity, of course, as soon as one starts giving advice on policy matters. And that is one of the reasons why some of the major scientific societies in this world have lost their way, because they have started to give advice to government on policy and they have accepted funding to give that advice. Now, Lord Monckton, who will be known to all of you, regarding the fact that dangerous global warming caused by carbon dioxide emissions not being a problem, because there's no empirical evidence for it, and many people in this room would probably agree with that. That's not to say carbon dioxide isn't a greenhouse gas, but empirically there's no evidence for a dangerous rate of warming caused by our emissions, or indeed any warming that's measurable. So in that context, Lord Monckton says the important thing to do about a non-problem is have the courage to do nothing. Now, I agree with that, but I also live in a real world. And there are so many important people right through the political, public, commentariat and scientific community that have vested their reputations in this dangerous global warming that you cannot do nothing. That is not a realistic policy alternative. And the reason I'm going to talk about policy in the second half of the talk is because I want to offer you a realistic policy alternative. Okay, so context, first of all, in a geological sense. We have here a slide of the last 6 million years of Earth history, and the temperature curve in red is a marine seawater temperature curve from the Middle Pacific Ocean, collected from deep sea drilling cores. And we are today at 0 million years here, and this is today's temperature. The measurements on here are oxygen isotope ratios, which we've already heard about. That can be translated into a rough temperature scale between warm and cold here. That's about a 10-degree change in temperature at Vostok, at one of the ice cores. And what we see straight away, because the question we would ask in context is late 20th temperature change unusual? And the answer is very clear. If this is today's temperature, then for 3 million years back here in what geologists call the late Miocene and the Pliocene, the temperature was 2 to 3 degrees warmer than today. Yet every month in Der Spiegel, you hear about this dangerous warming of the late 20th century and how it's unparalleled in history. Well, yes, it is unparalleled in the last 150 piddling years that is all meteorologists have to study. But in terms of context, there is nothing unusual whatsoever about this temperature here. Furthermore, not only was, for 3 million years here, the temperature 2 to 3 degrees warmer, but right here in the last interglacial, the temperature was about 2 degrees warmer than today. And I don't have the time to show you the slides, but if you then say, aha, Bob, it's not the magnitude, it's the rate at which the warming is happening, the answer is no, it isn't. There's nothing unusual about the rate of late 20th century warming in here either, compared with earlier geological rates. So in context, is late 20th century temperature change unusual? The answer is no. That is not my opinion. There are literally thousands of geological data sets that confirm that finding. You will note also that the planet was populated at this time by the plants and animals that we still have around us today. And they are mostly pre-adapted to a temperature 2 to 3 degrees warmer than today. The idea there's going to be a biodiversity crisis if the temperature goes up a degree or two could only be something that occurs to an ignorant person. Now, Professor Cortolo has shown this slide, and it's actually derived from Richard Linson's testimony that he gave to Congress a few weeks ago. And again, I want to look at internal climate variability and multi-decadal oscillations, and note that these are the individual monthly observations that go into the climate research unit's calculations. And we see straight away there's a lot of internal variability here, about a 4 degrees centigrade range of internal variability. We then go on to the average, which we've already looked at, and on the same scale, 0 to 4, 0 to 4, well, you can see the warming, but it's very small. And in the context of this range of variation, this doesn't look like anything that is terribly serious. But we never see it like this. We always see it like this. Plotted now, look at the scale, 0, 0.2, negative, 0.4, negative, 0.6, 0.2, positive. So the way in which the late 20th century rise is made to look alarming is by deliberately expanding the scale. This is graftsmanship. It's trickery. Here, we have a warming that took place between 1900 and 1940, and the warming in there is about 0.9 degrees Celsius. It's natural because it's prior to the post-World War, Second World War burst in carbon dioxide emissions. And here we have the late 20th century warming between about 1969 and today, and that's about 0.6 degrees. And this is supposed to be human, and that's supposed to be natural. But in context, this human so-called rise here is nothing unusual at all. It's the same slope as this, and it's in fact not as great in its magnitude as this. Now you can see here a multi-decadal cyclicity. And I'll come back to that. Richard Linson's second slide before the Congress was this one. It's his hometown of Boston, and it's the temperatures in March and April 2008. And what is plotted in the dark grey in here is the expected average high and low temperature for the day. And as you will see, it climbs very gently through the month, as you'd expect, because you're coming through into spring and later spring here. The blue bars are the temperatures that are actually measured. So on March the 30th in this year, it was 43 degrees or so was the high, and about 28 was the low. And that's a little bit below the expectation. Okay, and then the light grey in the background is the record lows and highs over the whole 100 years of record. So the variability of Boston temperature summed up by that, and the red line across the middle, the thickness of that line represents the range of the global mean temperature anomaly over the last century. It is very, very hard, looked at in context, to argue that that change is in any way dangerous, even were it to be known that it was human caused, which it isn't, of course, known. Well, Russian work from their major Petersburg Arctic and Research Center, so these are now not global figures, these are Arctic figures, demonstrates the multi-decadal oscillation very nicely. And this data set goes from 1900 to 2000, and it's then projected out to 2080. And when you fit this, a curve through this, you will see that the prediction is that for the next couple of decades, Arctic air temperature is going to decrease, and the ice cover in the North Polar Ocean will increase. So those of you that have bought shares in shipping companies, expecting to make lots of money because they're all going to go via the Northwest Passage, I'd sell those shares as quick as I could if I were you. Now, the version of this curve was first plotted in here, and the prediction was made that this was what was going to happen next. So this has, in a sense, had one validation test, and it passed it. That's not to say that it's necessarily going to be right down here, but it's had one validation test. None of the IPCC general circulation models have passed any validation test, and all 21, I think it is, of them projected that warming would take place over this same period from 1990 through to 2010. So they have actually, insofar as they've had a validation test, failed it. There is more than one type of computer model, is the message to take out of that, and this is a statistical or empirical model, and the statistical or empirical models are actually much more accurate, as far as we can tell from the tests we've had, than are the GCMs. Okay, well that's the context, if you like, of diurnal and then multi-decadal change. Now the context of human influence. This is an Australian average of 25 regional and remote country stations from 1882 through to about 1992. And what you see is basically no change over that time. A slight cooling trend and a slight warming trend. If we now take the 6 capital cities of Australia, and we find that we've got a very marked warming trend starting in the 1950s and coming up here. Now, this is attributed, not just in Australia, but in lots of places, to urban heat island effect. So we build Berlin and we replace original trees and grass with concrete, macadam, steel, glass, and that traps the sun's rays during the day and re-radiates it overnight more than the vegetation did, and of course that creates this little local heat bubble. Now, together with other independent scientists, I'm often accused of denying that climate change occurs, which of course is nonsense. It occurs the whole time. I'm then told, well, I deny that humans have any effect on climate. That's nonsense too. We all know humans have an effect on climate. Here's the evidence. But it's local climate. So, locally, humans cause, or human activities cause warming. But equally, and this is Melbourne as it happens, and the heat island over Melbourne, here's the temperature in the surrounding countryside, and over the middle of the city it's as much as 8 degrees warmer. Not surprising, because the temperature gauges are surrounded today by high-rise buildings and motorways. Now, so locally we cause warming, but out in the countryside of Western Australia, we have these magnificent wheat fields over a belt about almost 1,000 kilometres long, and here's the native vegetation that has been cut down to create those wheat fields. And it's quite obvious that its albedo is much less. It's darker. So the sun's radiation coming in now is reflected more off the wheat fields than it was from the original dark vegetation, and locally that causes cooling. So of course humans have an effect on climate. Locally they cause warming, locally they cause cooling. Now even an Australian can work out that if you add up all those little warmings and coolings around the world, there's got to be a net global signal. Has to be. Nobody I know denies that. You wouldn't be a scientist if you denied that. So what is it? Is it warming or is it cooling? Net, worldwide. We don't know. We can't measure it. If you can't measure it, you don't know. Now, most scientists, and especially the ones that are in that 30% that think they're the 100% experts, will tell you it's warming. And they'll actually give you good physical reasons and theoretical reasons why it should be warming. But that's their opinion. Until we can measure it, the reality is that not only can we not measure the signal, but we don't even know whether the net global signal is warming or cooling. Different sort of context now. You have a department store, forgive me, called Kaufhaus des Westens, or KDW, is that right? Well, in Australia we call it David Jones. And David Jones has branches around the country. And down here is our southernmost city, Hobart, capital of Tasmania. And the average annual temperature in Hobart is 10 degrees, believe it or not. You don't want to go there. Up here in Brisbane, and I live up here in Downsville, up here in Brisbane it's 10 degrees warmer. So David Jones' staff in Tasmania, because there's branches of these shops in both places, of course, often ask to be transferred to the Brisbane branch. And up they go, and they sit out on the patio, and they look out over the Pacific Ocean, and they sip their gins and tonics, and think, by goodness, this is great. And they then look at the map, and they say, well, look, what about this? It'll be warmer still. So up they go. They now get posted to Darwin, And this is another 8 degrees. So across the continent, we've got 18 degrees centigrade change in 3,000 kilometres. That actually works out at a degree in 150 kilometres. So if you jog, go over your morning jog, and you have a big jog and manage 150 kilometres towards the equator, that's 1 degree change. That's twice the probable change warming in the 20th century that is claimed. Well, that's horizontal. What about vertical? This is, I won't go into the details of this diagram, but you all know about the lapse rate, which is the rate at which temperature decreases with height in the atmosphere. And in the saturated atmosphere, the humid atmosphere, the rate is about 6 degrees centigrade cooler per kilometre in height. So that is 6 degrees per kilometre is 0.6 degrees in 100 metres. So that's the whole warming of the 20th century when you take the dog for a walk in the morning and climb up a hill that's 100 metres high. And we're going to stop the world, we're going to revolutionise our energy economy, we're going to crucify the landscape with all these windmills for that? Okay, that's enough context for temperature. Now I'm going to give you one slide for context for carbon dioxide. Remember, I'm a geologist. I'm only comfortable when this scale reads millions of years. And this time, it's 100, 200, 300, it's 500 million years. This is real good stuff. Okay, and 500 million years ago or so is the time at which the first metazoan multicellular fossils are found. So this is the period of time over which the planet has had, if you like, advanced life. And we've had jellyfish and little crabs and all those things, mollusks. And the various curves on here and the data points with big error bars are different methods of measuring or inferring ancient carbon dioxide levels in the atmosphere. It's difficult to do, which is why there's many different ways of doing it on this graph, and they're not very accurate, but they show an unmistakable trend, and that trend is down. And in the Cambrian here, 500 million years ago, on this scale, this is 1, this is today's carbon dioxide level. That's 5 times today's, that's 10, 15. So here, in the Cambrian, carbon dioxide levels were 15 times today's. Now, that's obviously a bit of a gross generalisation. Let's fit a better curve. That's a bit better, isn't it? Okay, something clearly happened here. Because this carbon dioxide here, 4,000 or 5,000 parts per million, where did it come from? Came out of volcanoes, of course. That's where all the juvenile carbon dioxide comes from. So we've got this rich carbon dioxide atmosphere, relatively. It's still a trace gas, but there's more of it than there is today. And then suddenly it gets drawn down around 400 million years ago. What draws it? What happened 400 million years ago? It wasn't an asteroid. What was it? It was plants, wasn't it? There we go. What do plants do? Well, they eat carbon dioxide. They love the stuff. So here we go. They take all that out of the atmosphere, and it comes down to this level, and I mean, there's a bit of variation in here, but it jogs along. So the context of carbon dioxide levels through time, here we are today, pre-industrial revolution, we had 280 parts per million. Right now, we've got 390 parts per million, and we did add most of that carbon dioxide, probably. If we double it, and that's what everybody is worried about, oh, we might double carbon dioxide, that would be 560 parts per million. It doesn't matter whether you talk about 280, 390 or 560, all of these numbers indicate carbon dioxide starvation. The idea that more carbon dioxide is dangerous in terms of the ecosystems we have on the planet is just silly. Commercial tomato growers, all of them, grow their tomatoes in 1,000 parts per million in their greenhouses. Why? Because the plants grow better that way. Plant physiology is adapted, mostly, not every plant, but many plants are physiologically adapted to significantly higher levels of carbon dioxide than we have today. Okay, context. This context is world climate. Now, there's been a few comments before about this statistic, global average temperature. And as a scientist, there is nothing I want to discuss less than global average temperature. I think it's scientific content. It has some use in arcane parts of meteorology, but it's really not a very meaningful measure. But you can't participate in the public debate unless you're prepared to discuss that curve. Just as there is no such thing as a global average temperature, really, unless you're sitting in a spacecraft looking back at Earth and you measure it spectroscopically, other than that, if you're on the planet, we don't really care what the global average temperature is. We very much care what is outside that window because we've got to go home tonight. Yeah. Okay, same with climate. Nobody lives in a world climate, right? This is the first climatic zonation map of the world produced by a Russian geographer and climatologist called Kirpin, and this was in the first 20 years of this century. This diagram with 28 major vegetation and rainfall zones is now in every elementary geography textbook around the world. If you live in Europe, then we've got the green is the temperate. This is the continental type, the blue here is the continental type climate, Mediterranean climates down here, and boreal and Arctic climates up there. Now, even within a particular climatic zone here, like Great Britain, the climate hazard up here at John O'Groats and down here at Land's End is actually different. Now, it's one climatic zone from our classification point of view, but up at the top there you get far more of the cold events of the air sweeping down this way in winter, and that's a big hazard. Britain is in its knees at the moment. You can't get to work, you can't get stuff to the shops, all because of a bit of snow, but it relates to cold air masses coming down here. Down here, you're more exposed to the Atlantic storms, and the big risk there, hazard, is huge Atlantic storms coming out. And of course, Germany, that applies to also. And climate hazards stem from local geographic setting. I live in Australia. I couldn't care less how much ice there is in the Arctic Ocean, right? But I do care about drought in Australia and the climatic hazards in Australia. Well, might as well stop now because there's no climate problem, is there? I mean, it's all local. So is there a real? Yes, there is a real climate problem. But it's not the one that's being talked about in the newspapers and everywhere else for the last 10 years. Here is the real climate problem. One 172 people lost their lives in those bushfires in Victoria in February 2009. The episode was caused by a major depression in the Southern Ocean, sweeping in towards Australia, and on the north side of it was a small trough, and as that trough went through, the fires were in this area. The firefighting appliances were all lined up, fighting a fire coming this way. Everything was more or less under control, and suddenly the fire turned around and went 180 degrees the other way as that little front went through. The winds were 30 knots on both sides of the reversal of the front, and enormous damage and loss of life was done. Meanwhile, at exactly the same time that was happening down here in Victoria, up in the north end of Australia, the monsoon trough was parked over the country, and the state that I live in, there, Queensland, received 1.2 metres of rain in 7 days, and in British or American terms, that's more than 6 inches a day for a week. As a result, 60% of Queensland was flooded and disaster declared. These are real hazards, and I know what you're thinking. This guy doesn't even know the difference between weather and climate. These are weather events, you're thinking. It's not climate. Well, yes and no. Mother Nature does not recognise any distinction between weather and climate. As far as Mother Nature is concerned, the processes that control the distribution of heat around the planet, and what the climate is the manifestation of the non-linear methods of heat transfer and distribution through two interconnected fluid envelopes, the atmosphere and the ocean. And the processes that do that, that transfer that heat, occur on all scales from microseconds, this is the microphysics of clouds that was spoken of earlier, formation of little ice nuclei, takes place in micro or milliseconds. And then at my end of the scale, drifting continents, Australia pulls away from Antarctica, creates a new ocean basin, and the southern ocean waters sweep through. And the oceans are a major transporter of heat around the planet. These are all climate processes, and there's no magic point at 30 years where nature says, oh, whoops, that's climate and this is weather. That's just an artificial statistical construct that we find useful, and it is useful in some specific positions in meteorology. But it's not, if you like, a God-given law of physics. In fact, it's not any law of physics. Okay, so climate hazards then range from short-term events like storms, cyclones, bushfires relating to droughts or periods of very dry and intense heat. And then on the longer term, they include these trends we're worried about, warming or cooling trends, and they include the steppes. All of these things are actually climate-related hazards. Here's Germany. You're prone to have storms in January, February, March. In 2007, 25 people killed. This one, March the 3rd, 2008, low-pressure storm system Emma. And this one, Storm Xynthia in March this year. So this is the major climate hazard in Germany. Okay, well, climate hazards are only one of the range of natural hazards that governments are supposed to deal with. What is the sovereign duty of a government? It's to protect its people. And the first thing to do is to secure the borders. We all accept we'd like to live in an ideal world and do without armed forces. It's completely silly. The government has to have a responsibility for protecting the borders. After that, the most important duty of the government is to protect its people from natural hazards. And all countries have rather different ways of doing this, but they have natural hazard agencies which get ready for and mop up after these sorts of disasters. But it's not just weather-related disasters. I'm going to go to New Zealand now as an example. One of their hazards is volcanic eruptions in the middle of the North Island there. And the next one is earthquake faults. This is the Wellington Fault. This is Wellington Harbour. And Parliament House sits right there, 200 metres from the fault. Nothing is more certain than that Wellington as a city, just like Los Angeles and Tokyo, will be one day destroyed in a massive earthquake with tens of billions of dollars worth of damage. It's not if, it's when. So if we were to make a list of hazards that the New Zealand government should worry about in terms of the risk of major costs, both in life and in money, then earthquake and volcanic eruption have to be right up the top. Now, that doesn't mean New Zealand doesn't have storms, landslides and floods and bushfires. Of course they do, but on the relative scale in New Zealand, they are lesser. But Germany, the chances of you having a volcanic eruption are virtually zero, and the earthquakes you get are being intraplate earthquakes, small and not a particular hazard. I don't want to discount them. Obviously, it's something you do need to know about, but nothing like in comparison with the damaging earthquakes you get in California, Japan and New Zealand. So you're down at this end, just as Australia is. These are Australia's major hazards too. So English colloquialism, horses for courses. The government's job is not to worry about global climate. The government's job is to prepare for the climate hazards that are going to impact its people in its particular little corner of the world. Horses for courses. All of these hazards are unpredictable and they're unpreventable. Exactly the same is true for climate change and sea level rise. You ever heard a politician promise to stop an earthquake? Oh, let's stop that volcano erupting. No. But you've heard them promise to stop climate change. That is every bit as absurd. It is just astonishing that reputable newspapers and reputable scientists, indeed world-famous scientists, will peddle this nonsense. Let's stop climate change, and let's stop it by emitting a bit less gas. Okay, well, New Zealand has a natural hazards centre called GeoNet with a list of hazards that it provides government with advice on, and that includes earthquakes and includes volcanic activity. But 5 out of the 9 hazards, droughts, flooding, landslides, snowfall and storms, are climate hazards anyway. New Zealand GeoNet. It's a world best practice system. On each tab here, this is earthquakes, this is volcanoes, landslides, tsunamis. We're on the earthquake tab, and here are the earthquakes in the North Island in the previous month. You can drill down through any of these earthquakes and find the information you need, advice on civil hazard, and this is providing advice both to the government for management purposes and to the population. There is no problem at all with adding another tab in here for longer-term climate change and sudden climate events. And you could give them $50 million, the scientists would be beside themselves with joy, instead of the trillions of dollars, trillions, that we're squandering on Kyoto and talking of squandering post-Kyoto. This is a more sophisticated diagram. You all saw the television coverage in the last, about a month ago, of the big earthquake in Christchurch. This is a little dynamic map of the aftershocks. There's now been more than 3,000 aftershocks, and they're all listed here by their depth of occurrence and so on and so forth. So this is the way to inform both the populace and the politicians, is to have proper civil defence organisations set up to do this. One last thing before I move on to policy. And the last thing is abrupt natural climate change. The two curves here are the temperature in Antarctica for the last 25,000 years and the temperature in Greenland. So a northern polar and a southern polar graph. Now, this is the last great glaciation. The temperatures are cold. This is the warm period we live in today, called the Holocene. Temperatures are warm, and this is where it warmed up in between over a period of about 5,000 or 6,000 years. Now, we look at Greenland and we think, gee, this is interesting, isn't it? What on earth's this? So we're jogging along here, we're very cold, almost like Baz out the window there, and suddenly, whoops, up it goes, almost to full interglacial warmth. And then over 1,000 years or 1,500 years, it back down to glacial cold, and then it, again, quite sharply, up to interglacial levels. This is called the YD, the Younger Dryas. It's a well-known climatic event. Note, it doesn't occur in Antarctica, or if it does, it's a much lesser manifestation, and many scientists think this is actually a different event. It has slightly different timing. And so if you're the government of Greenland, you've got to worry about this sort of event. If you're the government of Antarctica, you may be thinking more in terms of this. Horses for courses. The global climate's got nothing to do with it. It's what are the hazards here, where we're living. Well, the obvious question is, how long did this change take, and how long did that change? Those two warmings, how long did they take? Interestingly, paper in Nature last year, this change took place in 3 years. The next one took place in 6 decades. Is that first one a weather event or a climate event? It's just semantic, isn't it? They're all climate events. Okay, so in 3 years, we can go from almost a full glaciation to almost a full interglaciation. If we're policymakers, you can't possibly set policy without knowing about this and actually intellectually thinking it through. The idea you could stop this is, of course, absurd, but you do need to try and understand it. As a passing thing, I'll just fit the line for the last 10,000 years to these two data sets. I'm often asked by reporters, well, Bob, is global warming happening then? And I normally say it depends, which isn't a very popular answer. But is global warming happening then? No, it's cooling. It's been cooling for the last 10,000 years. As we come off the crest of the Holocene, this is called the climatic optimum, and we come down here, and here's the 20th century warming in here. Context again, perspective again, scale. The idea that 0.6 degrees of warming is dangerous is simply risible. Well, here we go. This is the end of March 2004, sorry, the 1st of March 2004. This is the Greenland ice core from which that Greenland climate graph we've just looked at came from. And here's the ice front running across the North Atlantic. The end of winter 2004. Here's the ice front modelled and reconstructed during Younger Dryas winters. There wasn't much shipping coming out of Rotterdam and Southampton in the Younger Dryas. You can grow sea ice over most of the North Atlantic in a year or two. I don't know a single nation based around the North Atlantic that has, as part of its public discussion on climate hazard, the possibility of a reoccurrence of something like this. Now, I'm not trying to start a new hare running. I'm not saying this is likely to happen tomorrow. What I am saying is it is profoundly stupid to be setting climate policies that do not take into account the context of genuine natural climate variation. The question, are we having an effect on climate, is a very good question on top of that. And when the Greens first asked it, back in about the late 1980s, isn't carbon dioxide greenhouse gas? Yes, it is. Aren't we emitting a lot of it? Well, not really in comparison with natural fluxes, but we are emitting more and it's accumulating. Well, then mightn't it cause danger? Yes, it might. So we should have a look at it. So we've had a look at it. We've set up the IPCC. 1990, 2008, 20 years. Thousands of scientists. How much money? More than $100 billion. That's sort of significant money has been spent trying to identify the global signal of human carbon dioxide emissions. And we haven't been able to do it. It's about time we shifted our attention somewhere else. And I agree entirely with Professor Cortelo when I say that what we need to shift our attention to is away from computer modelling and onto empirical data. Climate change, both warming and cooling, is a natural hazard on all timescales. So let's finish by asking a simple question such as your Minister for the Environment might ask. You might say, well, Bob, nice to see you here from Australia. I hear you know a bit about climate. Let me ask you a question. I've got this problem. I've got to set that policy on this. Will 2020 be warmer than today or cooler? Is it going to be like the Little Ice Age when the Thames froze over with 2-metre thick ice? Well, this is only 10 years away, Bob. I'm making it easy for you. These Peter Bruegel paintings look beautiful, but you and I know this was not a pleasant place to be during the Little Ice Age. We know the starvation, the famine and the plague that took place during that time. Or is it going to be like this, Bob? When in the north of England, the Romans were growing wine and reaping all these, and you could romp around in the hay with the local peasant women? Well, I know which one I'm voting for. So, in 2020, is it going to be like the Little Ice Age or is it going to be like the global warming period? What's the answer to that? Nobody knows. If any scientist gets up in front of you and says they know, then stop listening to them. Okay, so we don't know. So now what is the obvious policy? The mandatory policy? You have to be prepared for both, or rather I should say for either. So we need to prepare for either. Instead, we have this crazy plan A by the IPCC saying we'll stop climate change. Well, it hasn't worked, it won't work, and it can't work. It hasn't worked because the Scandinavian nations were early adopters of this, and they had a carbon dioxide tax, Norway, in the early 1990s through to now of about $20 to $30 per tonne. And what was the effect on carbon dioxide emissions? They went up 15%. So it hasn't worked. Furthermore, at the global scale, we know we've had the Kyoto Accord. We don't know exactly what it cost, but it's of the order of a couple of $1 trillion. Well, I mean, a small change, isn't it? A couple of $1 trillion, looked outside the window. Did the weather change because of the Kyoto Accord? Of course it didn't. It hasn't worked, it won't work, and it can't work. And it can't work because of a fundamental law of physics, or established principle of physics, and that is that the relationship between increasing carbon dioxide and increasing temperature is not a straight line. As many of you know, it is a logarithmic curve asymptotic to the axis. We are already up here. We can double carbon dioxide and the prima facie warming will be a degree or less. The only reason the IPCC tells you it'll be 3 to 6 degrees is because they put in positive feedback loops and ignore all the negative feedback loops. But just the carbon dioxide itself is about a degree of warming for a doubling, and if we doubled again, it would be less than a degree because of the logarithmic nature of the curve. So, plan A hasn't worked, won't work, can't work. What's policy plan B? Well, it's pretty obvious what it needs to be. But before I get there, meanwhile, we're spending money on things like emissions trading schemes and carbon dioxide trading. Al Gore is prone to say this is a moral issue, climate change. He's absolutely right. It is a moral issue, but in a very different way to the way he's thinking. Around the world, there are 1.5 billion people in underprivileged countries that do not have clean drinking water, do not have adequate sanitation, do not have elementary education, do not have basic health services. The United Nations estimates that for $60 billion a year, that's small change compared with what our politicians are squandering on global warming. For $60 billion a year, those problems could be fixed. British statesman, 18th century Edmund Burke, all that is necessary for the triumph of evil, and it is evil for middle-class, contented citizens in Western nations to expiate their consciences by thinking they're saving the world by riding a bike to work rather than driving their car. And that's you and me. If we do nothing, if we don't let the politicians know that this isn't on, nothing's going to change. Let's finish by asking a really simple question. The world won't be saved by Plan A, stop global warming. What will it be saved by? Well, this is what Europe looks like from the outside. I'm sorry to say this, but it does. This is the charge of the Light Brigade in 1854, and don't doubt the bravery of these men, but it was completely futile. And if you don't like that parallel, then the other way that Europe looks from the outside is like this. And this is just as futile, but this is stupid. But it wasn't King Canute that was stupid. King Canute is my hero. He was the first British empirical scientist. It wasn't King Canute that said, I can hold the tide back. It was his courtiers who said, oh, you are such a great king. You can even stop the tide. You can't, don't be stupid. Take me down there. And so they took him down there, and he said, stop to the tide, and it came up and wet his trousers. Brave and futile, stupid and futile. The obvious answer is adaptation. You have to prepare for, and as they happen, adapt to all climate hazards. And that is on a local and regional and national basis. Nothing to do with global climate per se. It's to do with the environment that you and the ecosystems around you live in. We then go on to the average, which we've already looked at, and on the same scale, 0 to 4, 0 to 4, well, you can see the warming, but it's very small. And in the context of this range of variation, this doesn't look like anything that is terribly serious. But we never see it like this. We always see it like this. Plotted now, look at the scale, 0, 0.2, negative, 0.4, negative, 0.6, 0.2, positive. So the way in which the late 20th century rise is made to look alarming is by deliberately expanding the scale. This is graftsmanship. It's trickery. Here, we have a warming that took place between 1900 and 1940, and the warming in there is about 0.9 degrees Celsius. It's natural because it's prior to the post-World War, Second World War burst in carbon dioxide emissions. And here we have the late 20th century warming between about 1969 and today, and that's about 0.6 degrees. And this is supposed to be human, and that's supposed to be natural. But in context, this human so-called rise here is nothing unusual at all. It's the same slope as this, and it's in fact not as great in its magnitude as this. Now you can see here a multi-decadal cyclicity. Okay, so context, first of all, in a geological sense. We have here a slide of the last 6 million years of Earth history, and the temperature curve in red is a marine seawater temperature curve from the Middle Pacific Ocean, collected from deep sea drilling cores. And we are today at 0 million years here, and this is today's temperature. The measurements on here are oxygen isotope ratios, which we've already heard about. That can be translated into a rough temperature scale between warm and cold here. That's about a 10-degree change in temperature at Vostok, at one of the ice cores. And what we see straight away, Because the question we would ask in context is late 20th temperature change unusual? And the answer is very clear. If this is today's temperature, then for 3 million years back here in what geologists call the late Miocene and the Pliocene, the temperature was 2 to 3 degrees warmer than today. Yet every month in Der Spiegel, you hear about this dangerous warming of the late 20th century and how it's unparalleled in history. Well, yes, it is unparalleled in the last 150 piddling years that is all meteorologists have to study. But in terms of context, there is nothing unusual whatsoever about this temperature here. Furthermore, not only was, for 3 million years here, the temperature 2 to 3 degrees warmer, but right here in the last interglacial, the temperature was about 2 degrees warmer than today. And I don't have the time to show you the slides, but if you then say, aha, Bob, it's not the magnitude, it's the rate at which the warming is happening, the answer is no, it isn't. There's nothing unusual about the rate of late 20th century warming in here either, compared with earlier geological rates. So in context, is late 20th century temperature change unusual? The answer is no. That is not my opinion. There are literally thousands of geological data sets that confirm that finding. You'll note also that the planet was populated at this time by the plants and animals that we still have around us today. And they are mostly pre-adapted to a temperature 2 to 3 degrees warmer than today. The idea there's going to be a biodiversity crisis if the temperature goes up a degree or two could only be something that occurs to an ignorant person. Now, Professor Cortelo has shown this slide, and it's actually derived from Richard Linson's testimony that he gave to Congress a few weeks ago. And again, I want to look at internal climate variability and multi-decadal oscillations, and note that these are the individual monthly observations that go into the Climate Research Unit's calculations. And we see straight away there's a lot of internal variability here, about a 4 degrees centigrade range of internal variability. Public discussion on climate change is bedeviled by a lack of context. And you've often heard independent scientists criticised, and in fact Professor Corteo referred to this, as not being real climate scientists, whatever a real climate scientist might be. Now, the people that use that terminology mean you're not a meteorologist or an atmospheric physicist or a computer modeler. In my view, that group constitutes about 20 or 30% of climate science expertise. In their view, it constitutes 100%. You will see during my talk where I think the balance of the context lies, and it lies in many other disciplines, and one of the very most important is earth sciences. My talk has two parts then. The first part is about context, and it's not particularly coherent in the sense that every slide follows from the previous one logically. Rather, it's a series of spot examples that I will give you to make you think about what is the context of this 0.6 degrees of gentle warming that we had in the late 20th century. Because we probably did have, well, if not 0.6, that might have some urban heat island effect in it, but certainly we had a few tenths of a degree of warming in the 20th century, and I want you to think about that in context. Then the second part of the talk I feel very uneasy about because I'm a scientist. And unfortunately, I'm going to talk about policy. And I feel, firstly, I don't particularly have expertise there, but secondly, one loses one's scientific objectivity, of course, as soon as one starts giving advice on policy matters. And that is one of the reasons why some of the major scientific societies in this world have lost their way, because they have started to give advice to government on policy, and they have accepted funding to give that advice. Now, Lord Monckton, who will be known to all of you, regarding the fact that dangerous global warming caused by carbon dioxide emissions not being a problem, because there's no empirical evidence for it, and many people in this room would probably agree with that. That's not to say carbon dioxide isn't a greenhouse gas, but empirically there's no evidence for a dangerous rate of warming caused by our emissions, or indeed any warming that's measurable. So in that context, Lord Monckton says the important thing to do about a non-problem is have the courage to do nothing. Now, I agree with that, but I also live in a real world. And there are so many important people right through the political, public, commentariat and scientific community that have vested their reputations in this dangerous global warming that you cannot do nothing. That is not a realistic policy alternative. And the reason I'm going to talk about policy in the second half of the talk is because I want to offer you a realistic policy alternative.